All right, so here's the layout. This is the touchscreen tablet. This is Rhino running in full screen mode. Pretty much don't need any of the commands from Rhino or Grasshopper. Everything is contained within the touchscreen and the middleware application. Different menus. These select the pages of the menu, starting with 2D and then moving through surfaces and libraries and analysis and final settings. 2D curve. Is this curve, top outline curve. Everything's toggled, elements are toggled on and off here. That's the main curve that defines the shape of the helmet. Here's the profiles. This is the shape of the equator in 2D, and then this is the shape of the equator pushed into 3D. Let's erase the 2D. So those are all of the curves that are main drivers at the start of the helmet. Change anything, you can adjust the width of the helmet here. You can adjust the length of the helmet. Very long. More conventional, everything updates in 3D. Let's just run through the menus real quick. This is the start of June in 2025. This is 2D outline. This is the belt line, which is the 2D shape of the equator viewed from the side. That's this view right. View right here is the belt line in 2D. Shape of the dome. Shape of the bowl. This is the dome right here in orange. The bowl right here in blue. Flip back, orange. These are all the factors. This changes, of course, the height of the dome. And again, the lengths can be changed here. These are all common to all the menus, but it's good to have them right there in the palette. Additionally, this is the mapping. This is the legend right here. This is the legend for what's available on this menu. The majority of the controls are mapped to the dial box. They're color-coded, so you can find them quickly. This top line corresponds to the top line of the dial box. The legend has the corresponding labels. So if you want to adjust the throw, this is the throw and this is the angles. There's two steps. This is the throw, which is right here. And this is pressing down on it, changes to the angle. And that adjusts simultaneously right here. And by pressing this pin button, it shows here, you can see on the screen right here, that puts in the dome entry pin, which is just kind of a visual indicator. Visual indicators for everything can be toggled on and off. This is the ratio of the curves front to back. This designates the tightness of that line. So if we want to make it really sort of conical to the middle of the line, we can pull it in like that. We can pull this back out, and we can also shape the ends of those curves so that we can push this curve out more. That's done with the throw. Coarse adjustments can be made there. Fine adjustments can be made on the dial box if necessary. If preferred, you can see an exact reading in millimeters here for the length of the throw. 61.554. Seems ridiculously fine, but with small adjustments, very low velocity, we're now changing in thousandths of a millimeter. The middleware captures all of the input. Normally these inputs would be lost as Grasshopper does the solution, builds all the geometry. Take a little bit more time once we get the solids in, but that would be, the middleware captures all of the inputs very, very fine because this is going at a quite high clip. Just move that down and then sends them intermittently to the Grasshopper solution. And when Grasshopper is going silent, it bundles all of these commands up, all of these messages that have come in, and sends them as a bundled message to Grasshopper, which is repeated a couple times to make sure it gets it. All right, let's go to the surface. We can generate a surface. We can preview a surface. This is a preview of the surface. Or we can check out the analysis. Turn that off. We can check out the analysis surface. This is has various degrees, various materials. This can be clay for some very dull looks, just when you're finding a form. Traditional alias look, or some high gloss materials to really take a look at things. Now this is using just the basic curvature here. Let's go back to dome, turn off the pins so we're not looking at those. Let's turn off the curves. Turn off the bell line curve right there. Okay, now we're just looking at the shape of the helmet itself. Got some little issues right there, it looks like, but we'll fix those up with the tightness. Let's take a look at it. We have different ways to look at it, not just materials in the analysis tab. You can also look at it with various forms of zebra analysis. Again, all of the aspects of the zebra rendering are able to be controlled here. The different amount of colors. There's a bigger set of colors. Palettes are here. Different palettes are available. Let's just stick with a basic palette. Element size can be reduced, as well as it's a little bit too small for video, as well as the gap size in between. So the gap size can be very small, big lines, or reduce them down to spaghetti thin lines for analysis. Look here, take a look at what's going on in the front there. We have a little bit of compression in the surface. Let's try and just extend that out. Let's go to the bowl curve here. If we can do this quickly, we will extend out that. Bring in the bottom surface here. Going to lift that up a little bit. Okay. Going to look at that ratio there. Going to go to the mono surface. That's tightening that up already. Those are a little bit more tangent now. A lot more tangent. When you go to a different form of analysis, which is looking at very fine sort of particle views of the surface. So we're going to go to render and go to a very granular image. It's like sort of a hand rendered piece, but it's very well for showing. It's got so many pieces in motion. It shows discontinuities in the surface quite easily. There's a cloud version here that's good for seeing if everything meets across the center line. Now, controlling the shape. This is the first rough shape, which is a fit between the perimeter and the equator lines, which are these curves right here. Just turn that off. These curves right here. Turn that back on. Let's take those curves off. This can be viewed with or without the head mesh naturally. Head mesh helps to maintain orientation. Now let's go back to the different forms of control over this surface. Okay, let's go to just simple clay here. Let's look at a simple clay version. Okay, basic clay. Now, let's highlight, going to the mono surface page, let's highlight the factors that are included in this solution. These are the active includes. These are the driving shapes, the driving shape for the surface, the magnitude, which is sort of this is the magnitude right here. Magnitude is the overall squareness of the sort of the pressure on the center line, which can be which drives the shells. That can be reduced to a minimum. That gives a very rounded view across this surface right here. Additionally, this magnitude can be tuned on 6 different parts of this surface. So there are pins, let's mono pins here. These are the different magnitude sections which can be tuned. So if we wanted to tune the entry, here's the entry right here. We're going to decrease that down. That's going to squeeze that. So now the driving pressure on this surface film, I'm going to think about it as a film, is decreased. We can go to the C. This is C right here. Monomag C. We have basically A, B, C, D, E, and F around the bottom. So if we wanted to drop C down to 0, we would drop C down to 0, B down to 0, or minimum. And now that's becoming very rounded on top. It's still in the back. It's got a bit of a flat spot, a bit of an extended curvature. All right, we're going to just bump those up a little bit, and we get the idea. All right, that's the idea. We can take a look at the same time, of course, in analysis mode. Here is a nice surface for dot surface. Let's go back and remove the display of the active includes. So we can see that. Let's also just remove the monopins. Okay, now we're just looking at it. Where an element here is round, sort of like right here, this orange piece right here, that indicates equal curvature on the surface. This is very much a long curvature in this direction, shorter curvature in this direction. All right, now we've got sort of this matchstick head shape, but let's take a look at what happens. Let's just quickly go to the edge surface. This is the edge cutting surface, which is going to define where the edge of this helmet is. And we're going to cut this helmet off now. Now, further into our menus, we have the strata. These are different layers of the helmet. So this right now, think of it as layers of an onion. These can be saved in up to eight different layers, so you can cut away, reveal, combine. We're going to set this initially to layer number 1. Layer number 1, and we are going to set the edge line, which is this current configuration here, which is of course all tunable. Can be looked up and saved to libraries. Library populates all the elements on the board as well for tuning. And then we can go to the matrix, the Boolean matrix, which allows us to take strata 1, which is populated, indicated by the green color, edgeline 2, which is edgeline, which is populated, put it as a solution, link those two, kind of like a patch board. So now strata 1 is being subtracted by the line. And we go to the analysis and we look at the prototype model. And there's the prototype model, which is this right here. That's cut out. We can remove, just for display purposes, the display of the cutting surface. And now we have a basic view of the parts that would be included in the final helmet. We're always working in Nurbs, so at any point this can be exported, this can be saved, this can be used as a basis for a 3D model for, of course, additional detailing. As many generations as you'd like to save can be saved. There's also a library. Let's see, let's go to the library. This isn't quite populated yet, but there are selections of head forms, the top 2 rows, and then body forms here of different levels of strata. There is a scoop library yet to be defined, and there's a mixing board. So once you get a shape and you've stored it into your library, here's space for 20 different shapes, infinite actually. And then you can move, and in between 2 shapes, you can blend all of the factors between any 2 given designs and come up with an infinite number of designs in between, and then use that as a jumping off point for further explorations. All right, there's a little bit in the Boolean matrix, the matrix page. A little bit of a visualization tool, which is the ability to roughly smooth it. Now this is done into mesh, but we can do the smoothing operation. And now we see it deteriorates the surface a little bit. We start to see the edge can be controlled in overall smoothing. It can be quite rounded. This happens with all. This also takes into consideration cuts that are introduced later in the process. There's a whole set of scoops and venting and cuts and sublayering that is in play that will be not part of this video. Go back to the Nurbs model right there. Go back to the analysis, render mode, take a look at it in a nice red material. There are times that the material capture file flips, so this flips the display. There's a check in there in places. Now, let's keep this right here as our working model, and let's examine the method for tweaking this surface. There's a lot of tweaks you might want to get full control over this surface. This is quite a rounded look, but let's say we want to have a little bit square in one area. So there are a whole series of tweak points. This is for each of the surfaces. There are 4 tweak points currently that can be controlled. This controls the display of the tweak point. So let me turn those on. They are now all starting lower on the helmet. Let's bump this up to full size here. These tweak points are on the surface of the helmet. Now, they can be moved up and down. They are color coded, starting with 1, 2, 3, and 4. All right, point number 1. Point number 1, this repopulates. Again, all of the controls are mapped over to the dial box. So this is point number 1, 2, 3, and 4. Want to go fore and aft or up and down? Let's just go up. It can be done very slow and fine here, or rapid adjustment here. All right, now we've got it located up there. We can move it up just a little bit higher. Move it up just a little bit higher. Okay, we see the ratio here, 82%, the distance up and down. And now we can control the magnitude of that point. Let's turn off the display of the other points just for eliminating the visual clutter. We have point number 1. Sometimes Grasshopper goes a little bit deaf during a solution, so the way is to toggle it back off again. Gone. Okay, now we can increase the magnitude. What this point does is pushes and pulls on this surface. So first we're going to do it without affecting the surface. We are going to move the magnitude outward. We can see the display. The amount registers on the pin. It is now moving 9.5 millimeters away from the surface. And now we have the choice to include that into the solution. Pins are by default not included in the solution. But if I hit the include tweak point 1, now that's included in the solution, and it pulls the helmet up in that area to that point. Now it's a very square look. Now this is of course all active, so I can decrease it here, or I can decrease it here on the dial box just by moving the magnitude down. See here, I'm going to go from 9 points to 6 millimeters. 9 millimeters to 6 millimeters. I can see it on the scale. Okay, 5.86. Okay, 5.8. And now, less square, fully adjusted, viewable in analysis mode as well. Analysis. We can watch the effect of tweaking that point in real time. Let's just watch the analysis here. Change the size a little bit smaller, element size a little bit smaller, a little bit higher resolution, a little bit bigger gap just for the sake of watching it, and go back to mono surface. Tweak point 1 is active. A massive change. And we see very clearly the effect on both the analysis surface. Curvature dots are getting much smaller. Curvature dots are getting much bigger here, indicating much more flatness to the surface. Let's dial those back down. Helmet catches up. These can be moved forward or backwards. This moves it forwards. It's going to move this point forward. It changes. all the way to the front. And now that sort of peak is moved out to the front, to the forehead of the shape. All right, so any of these points can be included. Let's just turn on point number 3. Point number 3 is shown. It's down below the helmet now. Go in the opposite direction. Let's go in the opposite direction here. Point number 3. Move that upward. Going to move it to the rear of the helmet. And we are going to push that a little bit more rear. I'm going to push that point inward. So I'm going to go from the middle line down. That pushes into the helmet, indicating minus 10 points. And now we're going to include that into the solution here. All right, that's quite a dent in the back now. But you can see for the sake of illustration the effect that has on the design. It pushes in rearward on the helmet. And this whole surface is then quite smoothly blended. So let's move that up a little bit. Let's just give that a little bit of a negative tweak. Okay, it's got a minus 2.4 millimeters. Over on the board, row number 3 is going to be, let's move it out. 1 millimeter. And the effect on the shape. Let's move it out. Let's move it up to, let's give 4 millimeters. A little bit of overshoot there on my controls. Have to work on that. Okay, 4 millimeters. Got a 4 millimeter pull on the tweak point. Very good. Let's. These are displayable or not. They still remain active even when they're not displayed. But the helmet is now a little bit more square shaped. All right, looking a little bit wide in the back. Let's just leave it for now. Let's look at the top view of the helmet. Just a quick demonstration of changing everything in play. So there's the top view of the helmet. Let's go to the top outline. This is the width of the helmet. Very narrow, very wide. This is the pin of the shape. This is a rotation of minus 5 degrees towards the front. It's a little bit wider in the back. This can be reversed, so it's got a little bit of negative taper. That's a little bit too much negative taper. Keep it there, and let's do the control points. These are the control points that control the shape of that helmet. So let's move the ratio inward a little bit here. Becomes a little bit more pin-tailed. Let's go to just a straight flatness and control everything with this here. A little bit further out. And if we want a real narrow ducktail here, we can change the throw of that line. So that's going to bring this in. And that pin is illustrated by this curve right here. This is the magnitude of the curve that's driving the whole shape. As well, we can show the front curve. That's the magnitude of that curve right there. These can be dropped down, again, controllable either by the touchscreen or the dial box. Everything is mapped on. The dial box lights up the controls that are active when each menu is selected. The angle on these is fixed at 90 degrees right now. It also can be tuned for a shape that has more of a crease down the middle. Let's go to final. Let's take a look at one more aspect here. Let's turn off the pins, just for eliminating the visual clutter. This is the curvature analysis. So this is the curvature of the top of the helmet. It is viewable in color with different thickness comb lines, with different densities, with proportional spacing, with inverted comb magnitude, with minimum and maximum comb lengths for visibility, with different palettes. Black lines, white lines, blue and white, etc. And labels as well. Finally, let's go to radius labels. That shows the radius in millimeters at any given point on the helmet. This density can be for each of the comb lines or at a fixed resolution. And this is available for all of the curves on a helmet. Let's take away the analysis right now. Let's just go back to a render. Go back to a dull clay render. Take a look at the dome curve and the analysis. That's the curve across the top in its relationship to fixed radiuses, which are both on the same scale. So the color of this curvature is the same for both curves, and it's unified. Turn those off. Final set of settings is for, this was the lateral shape. Before the tweak pins, the lateral curves, which are these curves right here, these curves were a lot more in play. Let's take that out for a second. These curves were controlling the shape of the helmet. This led to a little bit of conflict of definitions and some discontinuities in the surface that were difficult to control. So there's all the curves right there. These are no longer really in use. The tweak points have turned out to be the desirable solution. Lateral controls, each of those sections could have been controlled. For squareness, you make a very square helmet by throwing those out. They're both tied together. You can control the angles everywhere, but it led to conflicting definitions. These could be controlled wherever they arrive at on the curve, up and back and forth. But again, less of a desirable solution. Let's turn those off. Dome laterals off. Bowl laterals off. These are the main sets of curves together with the tweak points that are now controlling it. Go back to prototype model. Let's see here. And broken. All right, so that's going to do the demo right now. That's the state of things. Look forward to any responses you have. Okay, that's good. Thank you for watching. It's been a long one.